Alright, in this video I want to talk about graphing circles. Okay, now circles, if we include the whole circles, are not functions. If you draw any typical circle, um, let's say we put 4 points on this right here, draw a circle, it's not really a function because what's called a vertical line test, if I draw vertical lines through the graph, it hits at the graph at two spots. Okay, sometimes it'll hit at one spot, or maybe at no spots. But a function can only uh, intersect a line or the graph at only one spot to be a function. So we can kind of get around that if we actually divide this circle up into two halves, like um, the top half and the bottom half. Okay, and then somehow put them together. But for this video, I just want to talk about graphing. So it's not a function. Okay, so we're just going to say circle. It's definitely not a function. So a typical circle equation for a circle would be like x squared plus y squared equals 16. So the x squared and y squared tell us that the center of this is at 0, 0. All right, now that point is really not part of the circle, but it just tells us it's a device to help us locate part of the circle. So I'm going to put in a little x there, so we don't mistakenly think that that point is part of the circle. All right, the square root of 16 is 4, so that means from the center of my circle, which happens in this case to be 0, 0, I just go 4 out in every direction. So here's x equal 1, x equal 2, x equal 3, x equal 4. So I'm going to put a point here at 4, 0. And if I go from the origin and count up 4, there'd be another point. And typically that's what we do. We just draw points on the x and y axis. From the origin go left 4, and from the origin go down 4. So at positive 4 and at positive 4 on the y-axis, negative 4 on the x-axis, and negative 4 on the y-axis. And we just try to draw a curve around these points as best we can. And that's the graph of that circle. X squared plus y squared equals 16. What would we write for our domain? Again, keep in mind this is not really a function. We can substitute anything from negative 4 to positive 4. At x equal negative 4, we get an answer of 0. At x equal negative 3, we'll get some point up here somewhere, an answer of some kind. At x equal negative 2. So the domain, we're going to say, is from negative 4 to positive 4. Now, what would the range be? That's the problem, because it's not a function. All right, when we substitute, an easy one would be 0. At some point we get an answer of positive 4. At another time we get an answer of negative 4. So we can't really say what the range is because we don't have unique y values for numbers we substitute in. We could say that our y values, so let me change this to y values instead of range, because it's technically not a range. And interval increase, interval decrease, again, they would not really apply because we really don't have functions. Now we can say that it has x-intercepts at negative 4 and 4. Y-intercepts are negative 4 and 4. And we would not have a right-hand or left-hand behavior because this circle does not go off. So the main point is we want to know how to graph these. Okay, so let's focus on graphing. Alright, the next equation circle I want to graph is x plus, let's say x plus 2 squared plus y minus 1 squared, and we'll say that equals 9. Okay, and I'm picking very easy values. Okay, the easiest way easy values for circles are, if I pick that number to be a perfect square of some type, a 4 or a 9 or a 16 or a 25, that's be easy. All right, now how do I graph? I need a center. Okay, so the plus 2 is graphed, is grouped with x. So plus 2 means I'm going to shift left 2. Normally my center is at the origin 0, 0. I'm going to shift from the origin left 2. Now I'm not done yet. I just put a little x there at negative 2. Okay, now the y, there's a negative 1 group with a y. That means it's a shift in the y direction. Which way will you go? Well, negative 1 would kind of intuitively imply negative down 1, but when it's grouped with the y, when they're grouped together, it's really opposite what you imagine. So the center is, and let's write it down. The center is opposite of positive is a negative 2, and the opposite of negative 1 is a positive 1. Okay? So the center would be, left 2 would be actually right here at negative 2, positive 1. That's the center. And now how do you get the rest of the, again, I put a point there, and I put an X there, negative 2, and I put it in the wrong spot. There it is. Left 2 and up 1. There it goes. So that little X is the center of our circle. We're going to take the square root of 9, and that's what you always do. And that tells you what your radius of your circle is. The radius is 3. So from this first point, go to right 3. So place a dot from your little center, that little X, go up 3. Place a dot. From your center, go left 3. Place a point. And go from your center, go down 3. Place a point. And so that would be the graph of our circle. Alright, and I'm not going to talk about any characteristics again, because this really is not appropriate. It's not a function. And that's really all I wanted to demonstrate on circles.